Hello, dear students. This is the day, that is D-Day, whatever you have written. I hope it is well and your preparation, what hard work you gave for this entire academic year should and will give fruitful results. We as a team from ACE Engineering Academy and ACE Online from the Department of Electrical and Electronics Engineering welcome you to this live video presentation on the areas which did come based on the memory of the students. I won't say the data is 100% accurate, but we will do our best to give you as we progress through this live video. So have patience, be with us. There are some questions which we got very accurate. As a team, we had lot of faculty, the most experienced people with me, as you know, Nasimam sir, Basha sir, Baba sir, okay, Prasad sir. We will hear from them. So please do be with us, have patience, and we will have this great discussion going on. I want to ask some of the senior faculty. Yes, Kadar Basha sir from machines, can you elaborate about your subject?
Okay, sir. So hope everyone did your level best in the examination, and don't think after that whatever is completed you did well, and don't think much about that. And from machines around we have in total machines in 1 mark around 4 or 5 questions are there, and 2 marks question around 2 are there. So around 8 to 9 marks we got from entire machines. But according to the previous comparison, if you take, it is almost same, but compared to 4 or 5 years back, it is definitely less weightage we got this year also. But hope in the next year it will be better than this. Okay, let's see in power system also how many weightage, how many marks we got. So let's see from Professor.
Hello everybody. So as expected, we got more questions from power systems, nearly 5 2 marks questions and 4 near to 3 to 4 1 mark questions we got. So all the questions are very easy from power system point of view. Very basic questions they have asked regarding the Jacobian matrix and Y-bus formation, all those things they have asked the questions, right? And we got some questions, right? So if you are having some questions, please send the questions. We'll respond for the questions, right? And I will give to the next faculty, right?
As we want to even discuss, this time the paper is easy to moderate. Let me tell you, compared to all subject, after comparing and understanding whatever questions we have got, in general we have got, yes, easy to moderate. Okay, overall paper, yes, definitely scoreable. I expect your performance is better. Now let us listen from control, sir.
In control system, usually used to come 8 to 10 marks, but this year I think 6 marks only came. 2 questions from 2 marks, 2 questions from 1 mark. Till now we got that data. And one question, simple question they asked on race time, it is overdamped system. So still we are waiting for the questions. Okay, next power electronics survey.
At the same time, see, as we get the data accurately, we will definitely share with you. And in few days, once we get the question paper also, we will give the complete online solutions, nothing to worry. But let us hope whatever accurate data we have, with that we will proceed. Still, it is not that I say that signal we got only one question. There is a lot of data yet to come. And whatever data we present, we will be very accurate on that. That is assured from ACE Engineering Academy and ACE Online. I would now request Power Electronics sir to talk about his subject.
Yeah. So this time from Power Electronics, approximately 6 questions they asked, and total weightage is around 11 marks. Right? Few questions were received, and in coming time we will be receiving the remaining questions. Yeah.
I request now Signal sir to talk about his subject.
Hello everyone. As of the information given by some of the students, we got around 6 marks from signals, even from Mr. Aditya sir and Srikanth sir. 2 1 mark, 2 marks, I think. So till now we got only one question that is very easy on classification of systems. Now I'm handing over to analog sir, Kiran sir.
Thank you, sir. In analog circuits, we have got around 5 marks. Okay, 2 marks questions we have received 2, and 1 mark question only 1. There is one easy question on operational amplifier, so we will do that. They have asked to find the output voltage given the open loop gain of the op amp. Okay, we will do that problem. Over to mathematics
team.
Hi everybody. So as of now we received very few questions. As of now, one question we were given from eigenvalues and eigenvectors, I think from matrices, and one question from vector calculus, that is Gauss divergence theorem, and few more questions are expected. So waiting for that.
Yeah. Now we will start subject by discussion. Okay. Continuity we cannot maintain, as I have received some 4 questions accurately in networks. We will start with that. So be with us, sir. At the same time, don't give up. Okay, give us some time. In 2 minutes we will start the session, individual subjects based on the data what is available. It may not be 100% accurate. At the same time, don't lose hope. Continue to prepare. That is what restart is always my statement to say. Today is not the end of everything or everything. So continue. But whoever want to be with us, okay, let us discuss solutions accurately based on the available data. Okay.
Students, please send the questions, whatever you remembered, so that we can answer it.
Yeah, we have our WhatsApp group. So as you know, please do send immediately. Baba sir, Narsimam sir, Kiran sir, Max sir, Ramesh sir, Rajendra sir and Bada sir. Everyone is waiting for your discussion with us. Let us do that. Yes, myself Krishna Varma, faculty in ACE Engineering Academy and ACE Online since 2009. As you know, I teach networks here, electric circuits we call for EEE, and I got very accurate data from 3-4 students and one of my leading teaching assistant Venkat. And yes, accurately I got. There are approximately as of now 7 questions I got, but in that 2 questions data I could not get accurately. Remaining 5 questions data I got accurately. But still, okay, we will wait for the original paper to be released. Until then, don't worry. Maybe the values with decimals here and there, I can expect some change. So out of 7, see, imagine that it is now 7 questions, almost 13 marks. As per the data, networks or electric circuits, I got 13 marks. One of the heavy weightage subject this time. And relatively, I told in that 4 questions are very easy, 2 are moderate, and 1 is challenging. Okay, 1 transient plus steady state is that. Overall, I would say easy to moderate paper. Yes, before I start, yes, this GATE 2026 memory based question. So please understand, we are talking something based on the memory, okay, based on the memory based from the students and the teaching assistant who shared us, and electrical engineering. Now this is the accurate marks division we got. Now see this, okay, here as of now circuits see 4 1 mark, 3 2 marks, okay. So overall here you can say 6 plus 4 10, okay. Remaining 2 also I got, but I am waiting for the confirmation. Signals and systems, we got 2 1 mark and 2 2 marks. Power system 3 1 mark and 5 2 marks. See here, power system is dominant here. Power electronics also, you see 3 1 mark, 4 2 marks. Core subjects, it's good, it is a good sign, sir, core subjects. Then electrical machines 4 1 mark and 2 2 marks. Here also I can say 8 marks. Control system 2 1 mark and 2 2 marks. 4 plus 2 6 marks. Analog electronics, as of now we received 1 mark 1 and 2 mark. Still paper, I hope there are 2 more bits here. Digital electronics, we got 2 marks question, 4 marks. EMF 3 1 mark and 2 2 marks. Electrical and electronic measurements, okay, 1 2 marks we got. Engineering mathematics, yes, you see now 12 plus 3 15 marks as of now. Aptitude also, that is standard as of now, because that this area will never change. This area of technical subjects do change weightage here and there, but as of now this is the accurate data we are having, okay. Total, yes, 31 mark and 35 2 marks we got, okay. Now yes, let us talk about networks. Okay, now in networks, see, one of the question is Okay, sorry for the interruption. Now see here in networks, one question came that find the Thevenin's equivalent. Of course, he asked Thevenin's resistance and and this is the data here. From multiple students I got this and it is really accurate, I could say. There is one more voltage here. This is third volt, 90 volt, 10 kilo ohm, 10 kilo ohm, 10 kilo ohm. Thevenin's voltage is the open circuit voltage of the target. From the open output target. Now because he is asking us to find Thevenin's equivalent, now this becomes the open output target. Remove this 10 kilo, look from there. Now if you look from there, now if you go to step 1, yes, if you go to step 1 to find Thevenin's resistance, okay, or how to find RPS, this is category 1 problem. As you know, category 1 problem from the column to any independent sources, voltage source short, and luckily current source is not. So look from that point. And wherever voltage source is set, is a 10 volt source short, is a 20 volt short. Here also there is a 20 volt source short. Remaining resistance we give you, but they are redundant or not? You go into a resistance like this, approximately 10 kilo, 10 kilo, 10 kilo. But you see, this entire thing is shorted. So short circuit completing parallel to passive using here also this is. So the resistance seen here is directly the short circuit resistance. Wire is the one thing, ideal wire resistance 0. That is very straightforward because passive elements in parallel to passive elements in parallel to short circuit. Then when it comes to step 2, now step 2 is interesting. Let us find Thevenin's voltage. Okay. Now go to Thevenin's voltage. The given polarity. Okay. Let us see here. Equivalent of weightage. In the question itself there is polarity. Thevenin's equivalent of weightage is more. Is the equation. Yeah. So now if you see, this is about the given polarity. Now Thevenin's voltage is the open circuit voltage across the target terminals. Now for that what I will do, yes, if you see, to write this I will write a KVL. So this is the path where voltages already exist. So I will write a KVL in this path. Okay, let me write a KVL in this path. If you write a KVL in this path starting from here, plus VTH, okay, minus 20, minus 100, minus 20 is 0. So VTH is 140 volts. So yes, Thevenin's voltage is 140 and Thevenin's resistance is 0. So that is the answer. So in that option A, even in gate out of given options, option A, okay, option A I would say, where Thevenin's voltage is 140 volts and Thevenin's resistance is 0 ohms. Okay, that is correct. Now I'll go to the next question, sir. Next question is very interesting. Yes, the question is like this. Everybody watch this question. He said supply voltage is 325 sine 100 pi t and I is or Is is 12 sine 100 pi t plus 9 sine 300 pi t amperes. 300 pi t ampere. This is in volts, this is in amperes. Now the question is find the power factor. Okay, these are the excitation responses of any linear network. I won't say linear, let us say it is some network. Okay, it is some network. Source voltage, source current, and is asking us to find the power factor. Now by looking at the data, I told when you talk about power calculations, power factor, we categorize any subject in electrical engineering into 3 categories. One is sinusoidal supply to linear load, one is non-sinusoidal supply to linear load, one is sinusoidal supply to non-linear load. If you look here, supply voltage does not have harmonics. Supply voltage does not have harmonics, it is pure sinusoid. Okay. If harmonics come, then it is Fourier series, and you know Fourier series applicable only for non-sinusoidal phase. So because there are no harmonics, supply voltage is pure sinusoid. So yes, but you see current has harmonics like fundamental, third harmonic, fifth harmonic, something higher order harmonics you would have neglected. So giving voltage pure sinusoid but getting current non-sinusoidal means it is a non-linear load. So this case come under, yes, we studied or not? This case comes under sinusoidal supply to non-linear load. Non-linear load means I am sure in this box of load there are diodes or thyristors or MOSFET, something like that. So it is sinusoidal supply to non-linear load. Now because here you know how to calculate power factor there. There we have the concept of current distortion factor into fundamental power factor. So the other classical way is to directly go by P by S. Now if you go here P, first average power P, okay, it is only between fundamental because this product is 0, only fundamental, that is 325 by root 2 into, okay, 12 by root 2 cos of angle, but there is no phase shift here, cos 0, it is 1. So if you do that, you will get this as 1950 watt. Okay, then we will also do S. S is, yes, what V total RMS into I total RMS. What is V total RMS? 325 root 2 into I total RMS. If you do I total RMS including harmonics, one is 12 by root 2 square, okay, one is 9 by root 2 square. That you will get in VAs. Now if you take ratio, okay, if you take ratio, yes, that is what I am saying. Now power factor is P by S, okay, P by S. This ratio is giving 0.8 is the power factor. Okay, you do this calculation as per the data available. Yes, V1 RMS, I1 RMS, cos of 0. Why cos 0? Because between fundamental voltage to fundamental current there is no phase shift. But third harmonic current, okay. Okay, now students, yes, if you do calculation, first we got real power, active power, and we got total apparent power, and that ratio, okay, that ratio, yes, I am getting this as 0.8. But you remember this is category 3 sinusoidal supply to non-linear load. Now let us go to another interesting problem. See this question he gave. Okay, he gave a circuit with DC voltage source, and of course there is a diode and there is a resistor, inductor, capacitor. Okay, as per the data available, yes, this is VDC and diode, resistor, inductor, capacitor, and this is diode D. Okay, all are ideally mentioned, ideal, and is asking which element out of this are linear elements. Now you know, though we take ideally diode as ideal diode, but is it linear? No. Is it linear? It is a semiconductor device. You cannot say it is linear. But generally, fundamentally, our lumped parameters RLC are linear. So as per the data, he is asking which elements are linear. So the linear elements are RLC. Okay. Why? They obey Ohm's law. Do diode really obey Ohm's law? Though ideally diode is there, you know the static VI characteristics of diode, there is no homogeneity or proportionality. The real definition of linearity is homogeneity or proportionality. That exists only with RLC. So he is asking which elements are linear here. Okay. Yes, RLC are linear elements as per the data available. Yes, this is one of the simple question. Now this is another wonderful question based on the properties of sources. Now he said he gave 4 sources, okay, 4 source combinations. I will say source combinations. source combination he gave. Okay, he gave 4 source combination, where in one case he gave an DC voltage source and also dependent voltage source. Okay, this is the first combination. This is VD and this is some voltage Vx of course, which is K1 VD. Okay, now let us go to the second case, where again he gave a voltage source, but here there is a dependent current source. Interestingly, there is a dependent current source. This is again given as VD, but this current Ix, okay, this current Ix is 0.5 K2 VD. Third combination, see this source combination. Here he gave independent current source in series to dependent voltage source. Here he gave independent current source ID in series to dependent voltage source Vx, which is KT ID. And the fourth combination, again he gave an independent current source in series to dependent current source. So this is of course ID and this is Ix, which is 3K4 ID. Now he is asking these combinations are valid for what values of K1, K2, K3 and K4. He gave a lot of options, 4 options he gave, like K1 0, K1 6, K1 something he gave. So he gave these combinations of sources are valid for what values of K1, K2, K3 and K4. Very interesting. Okay, though I could not write all the options from the data what we got. Now see here. First of all, here voltage source and also voltage source. To satisfy KVL, both must be equal. Yes or no? Otherwise, it is a violation of KVL. When is KVL satisfied? When this is minus VD, this also should be plus VD. When minus VD plus VD, then only it is valid. Otherwise, it is violation of KVL. So K1 should be such that it should satisfy the KVL. Now, you to get that KVL, if it is minus VD plus VD only, it will come 0. So K1 should be 1. So K1 should be 1. K1 should be 1. That is pakka. Then only KVL satisfy, otherwise it is violation of KVL. Then here there is no restriction. Now see, there is a voltage source in series with current source. No problem. There is no restriction here. Let it be any value, it doesn't matter. But of course, the resultant of voltage source in series to current source is current source only. We know that. So this will be like current source. Here there is no restriction of K2. K2 can be any value, any positive or negative integer value, no problem, or any real number, any value, no issue, because there is no such confusion of KVL, KCL here. Of course, like current source dominates, current will be always this much. Maybe this is acting like a sink provided K2 is positive. Okay, so here there is no restriction because one is voltage, one is current. Now here also you see again one independent current source in series to dependent voltage source. Here also there is no such restriction. Current is always fixed. In a series combination, current is always fixed. This current will go here. Maybe it is again sink provided K3 is positive, but K3 does not have any restriction here. Again, this can be any value. This can be any value. But see this. Now this combination, but there are 2 current sources. Again here 2 current sources can be connected in series provided they satisfy KCL. Provided they satisfy KCL. If this is ID, you cannot have any value other than ID in the same direction. So ID here, this also should be ID. If this has to go down, K4 should be negative and the overall answer should be downward ID. Then only KCL satisfied. So the problem occurs with these 2 combinations are like here KVL should be satisfied, here KCL should be satisfied. Here there is no such confusion because current source is in series, current will dominate. But here if this is ID, this also should be ID. First of all, ID should go down this direction. So K4 should be negative and moreover this value should be downward, negative means minus ID. So what should be K4 to make this overall minus ID? Minus 1 by 3, minus 1 by 3. K4 has a restriction. So K1 should be 1, then KVL satisfied. Here K4 minus 1 by 3 itself is making it minus ID down. So KCL satisfied. So according to me, yes, K1 and K4 only have such restriction with unique values, but K2, K3 does not have any restriction. So in the given gate options, option 4 is matching. Okay. Yes. From the accurate data what students have given, option D is matching here. So let me write that. So here option D from that, okay, question paper. Yes, where K1 is 1, okay, K4 is minus 1 by 3, but K2, K3 can be anything, K2, K3 for all values, he gave for all values of K2. Okay, so this is a very interesting. So which combination will work? So it is all about checking KCL and KVL. Here voltage sources KVL, here current sources KVL. These two does not have any restrictions. Okay. Now if you look, now out of all, this is one of the fantastic question. Yes, this is the question he asked. Very, very good question. I think this is definitely 2 marks question here. Now here he gave the data, but challenging question because he asked both steady states and transient value also he asked. Okay, so this is 10 volts, this is 25 kilo ohms, this is 10 microfarad, okay, and this is voltage across capacitor V, and this is current I, this is current, okay, let me take this as V of t, this is I of t, and this is 100 kilo ohms. Now the question is like this, everybody watch this accurate data from 3 students I got, so I do believe this data, but still wait for the actual question paper. Here he gave that I of t is 1 U of t milliampere, milliampere is the unit, okay, and yes, now he is asking the question, okay, I of t, this 10 volts is there forever. Please understand what is the meaning of this 10 volts given, it is there forever, that means minus infinity to plus infinity, but here current source is coming at t equal to 0, but it is a step current of only 1 milliampere, and this is a capacitor, these two are resistors. Now the question is like this, so find the voltage across capacitor, okay, find the voltage across capacitor, that is V at A, okay, t equal to 0 plus, B at t equal to, okay, he asked at 0.5 seconds, and he also asked C V at t tends to V at t tends to infinity. See this question, sir. So he gave a very good question. Of course, this is a step current of 1 milliampere, and he is asking us to find the value of voltage across capacitor at 0 plus, at t equal to 0.5 and also infinity. So now these two are state questions, directly you can answer. Previous steady state and next steady state are very easy, but he also asked the value accurately 0.5, but he gave 3 values, sir. He gave very simple 3 values, and here let me tell you, with the given options, even if you get this first value and last value which are steady state questions, previous steady state, next steady state, in the option you can tick it directly, but still we will do the accurate solution. So these are like step response first order RC circuit, yes or no? Why? Because there is a step current of 1 milliampere. Step response first order RC circuit, original solution will be V of t equal to V of infinity plus V of 0 minus V of infinity e power minus t by tau. That is the complete solution. And you can also get, in the process you can also get these 2 questions also, because in capacitor it will not allow sudden change in voltage, V of 0 minus is V of 0 plus also, so you can get everything. Now if you go to first, yes, if you go to first V of 0 minus, V of 0 minus means previous steady state. Now if you go to previous steady state, this current source did not come because it is coming at 0, before 0 it is not there, but still voltage source exists here. So if you observe, there is a voltage source, okay, there is a resistance, but capacitor for DC access, current source is also not there, and this is our V of 0 minus. This is of course, yes, given as, yes, 10 volts, of course this is 10 volts, and these 2 resistors are 25 kilo and 100 kilo, okay, 25 kilo ohm and 100 kilo. Now this is our V of 0 minus, previous steady state. If you go to V of 0 minus, now voltage division rule, that is total voltage into same by sum, same is 100k by sum is 125k, okay, yes, you will get this as 28 volts, okay, sorry, you will get this as, let me correct it, 8 volts, okay, you will get this as 8 volts, okay. So this is the previous steady state, as current source did not come open, and for previous steady state DC capacitor is also open, voltage division rule, this voltage is total voltage into same by sum, you will get 8 volts. So now here in the asked bit, capacitor will not allow sudden change in voltage. If V of 0 minus, we got V of 0 plus, V of 0 plus, that is what is the first bit he asked, is also 8 volts, because capacitor will not allow sudden change in voltage, that is the first bit we got. V of 0 minus is V of 0 plus because capacitor, that bit, okay. So one option we got, that is 8 volts in the option. Then, okay, what is V of infinity? We will do that first, because next steady state also is required in the solution. Now let us go to V of infinity. V of infinity, the next steady state. Now next steady state, even current source came. Again, this is a DC voltage source, resistor, capacitor is open, but this time current source came, and this is another resistor. In steady state, again for DC excitation, capacitor acts as open circuit. This is again 10 volts. Of course, yes, this is 25 kilo ohm, 100 kilo ohm, and this current is 1 milliampere. 1 milliampere. Chalo, I need this V of infinity. Okay, now V of infinity is this, the nodal voltage here. You write the node voltage here. If you write the node voltage directly, let us write, okay, V minus 10 by 25k minus 1 milli, okay, plus V by 100K equal to 0. Now you solve this, yes, you solve this, you will get V as 28 volts is the next steady state. So, yes, 2 bits we got. V of 0 minus is V of 0 plus, that is 8 volts. V of infinity is the next steady state with current source included there, though it is a step current, but in steady state with 1 milliampere. So, DC 1 milliampere, yes. Now, he also asks a very interesting question, what is the value of voltage at 0.5 seconds? Now, for that we require solution. Now, for solution we got initial value and final value, but the challenge is to find time constant. So, let us find the time constant now. Now, let us find tau. Tau is R equivalent into C. Now, if you look at R equivalent, voltage source is short. Okay, this is where capacitor is connected, current source is open. Chalo, this is the R equivalent. This is 25 kilo ohm and this is 100 kilo ohm. So, if you look from here, what is R equivalent seen by the capacitor? This R equivalent is, these two are in parallel. 25 kilo is in parallel to 100 kilo. Okay, then however, tau is this R equivalent into C. If you do that calculation, yes, you will get this tau as, okay, R equivalent into C, you are getting something like 200 milliseconds. Of course, it is 0.2 seconds, means 1 by 5, that is 1 by 5th of a second. Now, if I write the complete solution for this, this V of t is equal to V of infinity plus V of 0 minus V of infinity e power minus t by tau phi t, t by 0.2, okay, phi t. So, this is the complete solution, that 28 minus 20 e power minus phi t volts is the complete. Now, he is also asking voltage at 0.5 seconds. So, V at t equal to 0.5 seconds, that is 28 minus 20 e power, okay. Yes, you will get this as half, okay, minus 2.5, okay. You solve this, sir, with that virtual calculator, and this also we got very accurate. It will be 26.36 volts, 26.36. So, the three answers are V of 0, 8, V at t equal to 0.5 seconds, 26.36, and V at t equal to infinity, 28 volts. Now, in that option D is the only option where you know these two also you can predict this. Actually, you need not do. See, you may say, sir, how can I do this in 1 minute? Though I am teaching the complete solution as we did it, okay. And in the given options, if you can just get this initial value 8 and final value 28, in between these two only that intermediate value will come. Na? That to time constant is how much? 0.2 seconds. Okay, and he is asking where? 0.5, almost 2.5 times of time constant. Yes or no? So, yes, the answer will be in this. Based on that also you can guess. Okay, remaining ulta he gave, sir. Some see in the given option, some options are V of 0 plus he gave 28, V of infinity 0 he gave no. So, you can guess it. These are the options. So, option D. Now, there is one more such question. I got the accurate data. Question number 39 is what the information I got. Okay, he gave a 2-port network. Chalo, he gave a network. Okay, and is asking, he gave a network like this. Okay, and is asking for what value of RL. Okay, for what value of RL. Okay, if it is a 2-port network, I need to get confirmation, then we will do in a different way. But as of now, with the given data from my student, yes, he is asking for what value of RL Pmax occurs in it. Simple. Pmax occurs in RL when RL is RTH. RL is RTH. Okay, that way if you do, yes, RL is RTH. You know, voltage source is shorted, this is shorted. Okay, so this is not working, but these two become parallel. Yes or no? Simple. Okay, these two become parallel. One is 10 ohms, is in parallel to 4. So, this RTH is RL, which is of course 10 in parallel to 4, that is 40 by 14 ohms. Okay, 40 by 14 ohms. That is what is the data as of now. So, as I do get, still there are 2 more questions, but I am still waiting for the accurate data. The data, one Norton's equivalent he asked from the given graph, but data I could not get accurately. One student was telling, as I get that accurately, I will definitely present in front of you. Stay tuned. Okay, I will request now measurement sir to come forward and talk about his subject. Okay, just have patience, sir, but still don't give up, don't get disheartened. Okay, and those who did well, congratulations, but others restart. Don't wait, don't worry about the result. As you keep linearly growing, opportunities do come. Don't give up is my sincere suggestion. Okay, now I'll request measurements sir to take it forward. Okay.
Hello everyone. Now I'm going to talk about the measurement questions. As of now, we got the information like 2 marks question from the bridges and one more 2 marks question from the current transformer. But as of now, we have received the question only from the bridges. So I'm solving that. Here the question is given like one bridge is there, 4 branches are there here, and P value is given as some 2000 ohm, and this is Q given as 500 ohm, and this R is given as 3000 ohm, and Q value is dash, and he has given that some voltage source value like this, some voltage source value is there. It is having some internal resistance also given, some resistance is there, and he has given galvanometer resistance also given. But what he is asking, under balanced condition, right, find out the value of Q. Now very simple. Under balanced condition, this potential and this potential both are equal, then automatically the current through this will be 0, means this can be removed. So therefore under balanced condition, this circuit becomes like this. This is 2000, this is 500, and this is 3000, and this value is unknown. And here whatever may be the voltage source value, resistance value not required, and under this condition, what is that? Opposite branches multiplied, Q into 2000 is equal to opposite branches multiplied 3000 into 500. So this is what the value, and if you are simplifying this, Q value you are going to get as 750 ohm. Very simple question. To confuse you, they have given internal resistance of the source and galvanometer resistance is given, but not required. Why? He is asking under balanced condition. Under balanced condition, no use of this element, it can be open. Therefore, if these two are equal, what is it? Opposite branches multiplied. So therefore here 3000 into 500 by 2000. If you simplify this, 3 zeros, and you will be having a 750 ohm. And one more question we need to receive, that is from CET. After receiving that question, I am going to solve that question. Clear? Next, power system faculty will continue.
Right students, welcome back. So now we have completed GATE 2026 examination, and we got some more questions from power system. So 5 questions, 5 2 marks questions, and right, nearly we got, and students told that 5 2 marks questions and 4 1 mark question, and out of that we got a very less number of questions information. So if you send the questions, we will discuss those questions also, students. So from the questions that we have obtained, so this is one question regarding the Jacobian size. So there is no clarity about the options they have given here. So consider generator buses, so number of PV buses. But there is no information about the slack bus. So that out of these PV buses, we can remove one bus and we can give it to the slack bus. So that number of slack buses, it will be 1, and number of PV buses, it will be P minus 1, right? And number of 50 buses, n minus PV buses minus n minus P minus. These are the number of PQ buses. Therefore, number of unknown deltas right. Right, students. So the number of unknown deltas at every bus, we don't know the value of delta except at slack bus, so that it will be n minus 1. And number of unknown voltage magnitudes, it will be number of PQ buses, that will be Q. Q, it is n minus P minus 2. So that the option may be, right. So it is total number of unknowns. Total unknowns will be, how many unknowns will be there? N minus 1 plus Q, this is one answer, or otherwise n minus 1 plus n minus P minus 2. How much it will be? 2n minus P minus 3. 2n minus P minus 3. Right. So that size of Jacobian will be 2n minus P minus 3 cross 2n minus P minus 3. This is one option. Or otherwise we can write it is n minus 1 plus Q. It is n minus 1 plus Q cross n minus 1 plus Q. Right. Based on that one, whatever the options we are having, please change that option. Right. I am changing any one option. I am writing here, it will be n minus 1 plus Q cross n minus 1 plus Q. Like that you can write any one option. This is one question based on the options, right? We don't have clarity about the options, students, right? And one more question. So it is given in economic load dispatch. I told many times, students, economic load dispatch default we are going to get 1 2-mark question, right? So they have given the cost of generator 1, the cost of generator 2, and the total power loss are also given. The total load demand is given 1184 megawatts, and lambda value default given 70.25. Right? They are asking what is the power loss in megawatts? What is the power loss in megawatts? See, we can calculate incremental fuel cost of plant 1. What is the incremental fuel cost of plant 1? It is 50 plus 0.02 Pg1, right? And incremental fuel cost of plant 2, it will be 50 plus 0.02 Pg2. 50 plus 0.02 Pg2. And these two values, right, whenever they are multiplying with their penalty factors must be equivalent to lambda, right? So that L1 into IC1 is equivalent to L2 into IC2. These two should be equivalent to lambda. We will concentrate on this one, L2 into IC. What is L2, students? L2 is nothing but 1 by 1 minus ITL2, incremental transmission loss of plant 2. What is the incremental transmission loss of plant 2? ITL2. ITL2 is nothing but dou PL divided by dou PG2. Differentiate the power loss equation with respect to PG2, students. What is the PG2 equation we are having? It will be 0.01 into what is that? I'm not differentiating now. I will differentiate later. It will be d by dPG2 of 0.01. It will be Pg2 square plus 50 square minus 100 into Pg2 minus 100 into Pg2. Right. So this will be 0.01 Pg2 square plus 50 square plus 100 into 0.01. It will be 1. This is Pg2 minus Pg2 minus Pg2 d by dPg2 d by dPg2. Right, students? And differentiate that equation, we will get ITL2 is equivalent to 0.02 Pg2 plus 0 minus 1 minus 1. This is the ITL2. Calculate L2. What is the value of L2? 1 by 1 minus ITL2. Substitute the value of that one. It is 1 by 1 minus ITL2. It is 1 minus 0.02 Pg2 minus 1, which is equivalent to lambda. Right. This is the value of L2. This is the value of L2. Once we got the value of L2, right, students, this will be 1 by 0 minus 0.02 Pg2 minus, right. So it will be 2 minus 0.02 Pg2. This is the value of L2. Once we got this L2 value, we are having L2 into IC2 is equivalent to lambda. Substitute the value of L2. It is 1 by 2 minus 0.002 Pg2 into IC2 value we are having 50 plus 0.02 Pg2, which is equivalent to lambda 70.25. Multiply this one here, it will be 50 plus 0.02 Pg2, which is equivalent to 70.25 into 2 minus 0.02 Pg2. Right. Calculate the value of Pg2 from this one. Right. We will get the value of Pg2 from this equation. Calculate the value of Pg2. After calculating the value of Pg2, calculate the power loss value. So what is the power loss is equivalent to? Directly it is given. It is 0.01 into Pg2 square, Pg2 minus 50 whole square. Substitute the value of power Pg2 whatever you have calculated, and from that one we are getting this one. Right. So for the data I am getting this as nearly 174, and I am getting this power loss as 153 megawatt. Right. These values may not be correct. Why? Because based on the data obtained, we have calculated this one. But just go through the solution. This is the procedure. This is the proper procedure to calculate the power loss. Very, very simple basic question. 2 marks question they have given from the economic load dispatch. Right, students? So we will see one more question here. Right. So this is the next question. Direct statement only. Na? This question related to the tap changing transformer. The tap changing transformer with half nominal tap ratio, which is a complex number. Right. We are having the ratio of IP to IS is equivalent to YT, right, minus YT by A minus YT by A conjugate, right, and this is minus YT by A square, YT by A square. They have given the value of A, students, 0.866 plus J 0.5, and based on that one they have given the options, right, direct options. So from that one just see the 4 options they have given. From 4 options which is matching this one, that will be the perfect answer. Right, students? And one more question they have given. Yeah, very basic part of transmission and distribution, students. T and D. Here given line is of resistive nature. Given line is of resistive nature, and delta 1 is equivalent to delta 2 is equivalent to 0. That means there is no active power flow between buses 1 and 2. Right? The line is of resistive, so that we are having only P loss, but no Q loss. Right. And whereas here this is purely inductive in nature, there is no resistance. So that here we are having only Q loss. There is no active power loss. This is purely inductive, we are having only Q loss. This is purely resistive. We are having only P loss. Got it right, students? So that they are given that P loss in case 1 will be more, right? P loss in case 1 will be more, and Q loss in case 2 is more, right? Q loss in case 2 will be more. This is one of the question from basics of transmission and distribution. I told many problems based on this one, right? And don't use the formula. What is that? P is equivalent to EV by X equivalent into sine of delta 1 minus delta 2. Equation is not valid for this one. This equation is not valid for this one. That equation is valid only for the inductive transmission system. That equation is not valid for the resistive system. Right, students? We have to do the different calculations based on the current conjugate. S is equivalent to VI conjugate formula. We have to do the separate derivation. But asked question is in the basics of P loss and Q loss. Directly we can give the answer. Right, students? No need to use the formulas. And just I got one information that there is a question related to the reactance relay characteristics. Students, the reactance relay characteristic in Rx plane, in case of Rx plane, it's a straight line. It's a straight line, right? It's a straight line. This is resistance axis, this is the reactance axis, and here we are having the Rx plane. But if you go to the GB plane, in case of GB plane, we are going to get a circle, right, which is in this quadrant, which is in this quadrant. We have to calculate the admittance value, y is equivalent to 1 by R plus Jx, and rationalize this one, R minus Jx divided by R minus Jx, and based on that one of the option they have given like that. The students told that there is a question related to reactance relay, right? In Rx plane it will be straight line parallel to resistance axis. In GB plane it's a circle. Right, students? Like that we can give the answer. These are the some of the questions we got from power systems. A clear discussion will be given for the questions once we got the question paper. Right, students? సబ్జెక్ట్ నేను చెప్పాలి, అందుకనే మళ్ళీ చెప్పేస్తే మళ్ళీ అదే కన్ఫ్యూజ్ అవ్వాలి కదా మాస్టర్.
Everyone, let's see the questions from machines up to now. Whatever we have received, let's see the questions available here. So this question is from synchronous motor. First read the question. A certain application requires power at a frequency of 16.67 Hertz, while the available grid frequency is 50 Hertz. So we need a frequency of what? How much here? 16.67 frequency, 67 Hertz frequency required. A three-phase synchronous motor connected to 50 Hertz three-phase grid. Okay, synchronous motor first operated by connecting to grid, driving synchronous generator is used for this application, driving a synchronous generator. Synchronous motor driving a synchronous generator, and the synchronous motor frequency is what? Grid frequency 50 Hertz. Okay, now the synchronous generator is driven by synchronous motor. Which one of the following combination is suitable choice for the number of poles in the motor and generator respectively? But here poles only not given. How many poles are there for synchronous motor and how many poles required for synchronous generator, so that we will get a frequency of 16.67 from the synchronous generator. Okay, so there is a grid, and from the grid first we connected to what? Synchronous motor. This is synchronous motor, and this synchronous motor is driving a synchronous generator here. A synchronous generator, let us take. This is synchronous generator, this is synchronous motor. So motor is taking a frequency of what? 50 Hertz from grid it is. And now from the synchronous generator we need a frequency of 16.67 Hertz, which is 50 by 3 Hertz it is. Now for that, how many poles required here and how many poles required here? So which combination suits for this? So very simple. So let us check according to options first. Let us check first 6 poles. In case of synchronous motor, let us assume 6 poles are there. If it is a 6 pole in synchronous motor, what is the speed synchronous motor rotates? Synchronous speed always. What is synchronous speed equation? 120 F by P. So then 120 50 divided by 6 poles, we get 1000 RPM it is. Okay, so synchronous speed 1000. So rotor is rotating here 1000 RPM. Now alternator, synchronous generator also rotating at same speed. And how many poles required here? That is the question. For what frequency? 16.67. What is the formula for frequency? Actually N into P divided by 120 frequency. How much frequency required for us? 16.67, which is 50 divided by 3. Now what is the speed this generator is rotating? 1000. 1000 into, so poles is unknown here, divided by 120. This is equal to 50 divided by 3. Now simplify this equation, we get the poles here around 2 poles we get. So synchronous motor 6 poles and alternator or synchronous generator 2 poles. So which one is satisfying? 6, 2 is satisfying here. Okay. Next question. See this question. See the question. A 220 by 12 volt. This is from transformer given. Read the question. It is MSQ model. Let's see the question and options here. A 220 by 12 volt single phase transformer is designed to use in India at 100 volt ampere 50 Hertz frequency. So Indian frequency. So later this unit is shipped to the USA, where it is used as 110 by 6 volt it is. 110 by 6 volt. Okay, half of that. Now this transformer is operating at which frequency? So US frequency is 60 Hertz frequency only. Now which of the following statements is or correct in this? So simply here we have seen already in the actual classes, like voltage frequency variation. How much voltage frequency initially the transformer is operating in India? 220 volt divided by 50 Hertz. V by F ratio it is. Flux density proportional to voltage to frequency ratio it is. V by F ratio. Now when it is shipped to US, there the frequency is 60 Hertz. And what is the voltage it is operating at that time? 110 volt. So voltage is almost half of that. Voltage is half. Now new voltage is 110 volt and new frequency is 60 Hertz. Then what happens to flux density? Check here. Voltage reduced and frequency increased. Then overall flux density so much decrease. The flux density of core will be so much decreases for US conditions it is. Okay, compared to Indian conditions 220 by 50. So here the 220 by 50 value is very high compared to this 110 by 60 Hertz. Now let's see the options here first. First option here is, for the same load current, the losses be highest in the USA compared to that of in India. So losses in US transformer is given as highest. So is the losses is highest for the same load current. See, load current same, resistance of winding will never change, even frequency changes. Maybe copper loss remains same here, but what about core losses? So if you consider this condition, no, V by F ratio is not constant, no, in both cases, 220 by 50, 110 by 60, V by F ratio is not constant here. Okay. Now which case it is according to our relations? Case 2 it is in iron loss topic. Now in the case 2, we know hysteresis proportional to voltage power 1.6 divided by F power 0.6. Now what is eddy current loss relation here? Proportional to voltage square. Okay. Now what is the voltage reduced and what is the frequency increased? So definitely hysteresis loss decreases here. And what about eddy current loss? As voltage is almost half, eddy current loss is 1/4. Means overall core loss is reducing. Even the copper loss remains same for same load current. So as iron loss or core loss reduce, what are the losses in US transformer case? Definitely less, but they given it is losses be highest in US compared to that of India. So this is wrong statement. Now second, the eddy current losses in core would be approximately 44% higher while operating in the USA. So while operating in USA, what is eddy current loss? Decrease, not higher it is. So this is also wrong. And third, the peak magnetic flux density in the core would be higher while operating USA compared to that of India. So flux density we have directly verified. No? What is the flux density here? Check this. Compared to 220 by 50, this flux density is, so it will come around 4.4. It will come around 1.8 something, this flux density proportionality. So here it is less, but they given higher in case of USA. So this is also wrong. No load current drawn would be smaller for operation in the USA compared to that India. Yes, no load current is small. Why? Because no load current is what? Sum of the two currents, magnetizing and iron loss current, two currents. So whenever density is decreased, magnetizing component of current decrease. As iron loss decrease, IW also decrease. Then what is overall no load current is less for which condition? US condition. So that is only correct here. Option D is the correct one for this. Okay. Next, see this question. Which one of the following options is correct regarding the typical double squirrel cage structure used in induction motor? Double cage rotor simply. So in a double cage rotor, no, in every slot we have two windings. In one slot, two windings will be there. One is the smaller size, one is the larger size. So outer cage will have small size or small cross sectional area of conductor, and inner will be little large size. So why we use double cage first over normal squirrel cage? So because in normal squirrel cage the drawback is rotor resistance will be less, copper bars. So starting torque will be less. So one of the method we use to increase the starting torque is double cage induction motor. So how we design is, two cages will be there, inner cage and outer cage. So outer cage conductors will be designed with small area, so that small area means what is the resistance? Very high. So outer cage will have high resistance and inner cage will have low resistance. And which cage is responsible for good starting torque? Is outer cage is responsible. And see the questions here. At the starting, a large portion of rotor current flows in the inner cage. Large portion of rotor current. At starting, large portion of current of the rotor current flows in outer cage. So at the time of starting, which cage is responsible for good starting torque? Is outer cage only. So current flows in outer cage at the time of starting. But once it comes to running condition, total current shifted to inner cage because it will have low resistance and current can pass easily in that. But at the time of starting, the overall impedance of outer cage will be less. Outer cage will be less. That's why current flows mainly there. But it will have high starting torque because of high resistance in that. Outer cage will have high resistance, but overall impedance at starting will be very low for this. But inner cage will have low resistance, but its impedance will be higher. Okay. So based on that, the mainly current under starting condition will be in outer cages only. That's why at the time of starting, a large portion of the rotor current flows in inner. At the time of starting, a large portion of rotor current flows in outer. So answer is here outer case, starting event. Okay, running condition current will be in inner case. Next, this is from auto transformer. So this type of questions regularly we are getting in gate, mostly every year will be there from auto transformer. See this, a 15 kV 1100 by 220 volt single phase 2 winding transformer is configured as 1.32 kV or 1320 volts by 1100 volts auto transformer. Then what is the kVA rating of auto transformer? So direct formula available. What is that? kVA of auto transformer is equal to 1 by 1 minus k into kVA rating of 2 winding transformer. Directly use this, 1 divided by 1 minus k. What is the k? Auto transformer k, low voltage by high voltage. For this rating, low voltage is 1100 divided by high voltage 1320 into what is the kVA rating of 2 winding given 15. Now if you simplify this, we will get 90 kVA it is. This is 90. So answer is 90, option A for this. Next question. See this. The figure shows the single line diagram of a synchronous generator delivering 50 megawatts of power at UPF to the infinite bus. Now here alternator connected to bus bar or infinite bus or grid. So where it is operating initially at unity power factor given, at unity power factor. Now what happens, IS denotes the stator current per phase. If the field excitation is increased, already operating at UPF, now field excitation increased, which of the following options correctly describes stator current and power factor and angle? So what happens to load angle whenever excitation increase? So this is simply from V and inverted V curves, no? V inverted V. This is power factor, armature current and field current. So V curve is the armature current, power inverted V is the power factor. So we know this is unity power factor, maximum is 1 UPF. At UPF we call it is normal excitation. At this normal excitation always generator operates at UPF. This is over excitation, this is under excitation. What is over excited power factor? Over excitation power factor is always lagging, under excitation power factor is always leading it is. Okay. Now whenever field current increase, what happens to armature? Right now it is at UPF. From now excitation increase, then what is the armature current increase and what is the power factor value decrease? And what is the power factor here? Mainly lag. Over excited machine always lagging power factor. Now see that stator current decrease and stator current increase, power factor becomes lagging, load angle remains same, and your stator current should increase, power factor becomes lagging, load angle decrease. And there is one graph separately for load angle with excitation. Whenever excitation increased, always load angle decrease. So as excitation increasing, load angle decreasing, then which option satisfied? C. Current increase, power factor becomes lag and load angle decreases. So C is the answer for this. Okay. Next. A balanced 3-phase supply is given to a 30 kilowatt 4-pole 400 volt 50 hertz wound rotor induction motor. Okay. Wound rotor means slip ring induction motor, star connected stator and rotor windings. The motor is drawing constant torque load with shorted slip rings here. The machine running initially at 1476 RPM initially. Okay. When an external non-inductive resistance, means now external resistance is added, how much added? 0.27 ohms added per phase. Then the speed of the motor drops to 1404. So rotor resistance control simply. So when there is only rotor resistance R2 without any external resistance, what is the speed of the motor given? 1476 RPM it is. Okay. 4-pole case 50 hertz means synchronous speed is 1500 RPM here. Synchronous speed 1500 RPM. Now after addition of some external resistance, how much external resistance given? 0.27 given, 0.27. Then what is the speed of the motor? What is the speed of the motor? 1404 RPM. 1404. Then question actually here, how much is the rotor resistance? That is not given. As torque is constant, no? What is the condition according to rotor resistance? The ratio of slip to the rotor resistance should be constant. So before addition of resistance, we have S1 by R2. After addition of resistance, the ratio is new slip by R2 plus RE. It is R2 by S2 by R2 plus RE. Now S1 calculate here. S1 NS minus N by NS. S1 we get S1 equal to 1500 minus 1476 divided by 1500. Calculate. Similarly, S2 also calculate because new speed also given 1404 here. 1500 minus 1404 divided by 1500. Calculate S1, S2 values. S1, S2. So the S1 value is coming 0.016, 0.016 and S2 is coming 0.064. Cross check these values from your end and finally substitute here. S1, S2 everything is there except R2 value. So calculate R2 from this equation. It is coming 0.089 ohm per phase, okay, or 0.09, let us check. So this is rotor resistance coming, cross check this value once, okay. No, next question. Now this question is from vector group of 3-phase transformer. So actually in a delta delta connection, most we use only two connections which are 0 degree and 180 degrees, or 12 o'clock, 6 o'clock. But here it is coming some different based on the connection. Whatever they given, accordingly we have based on the data available. You see the connection is made with a sequence, a three-phase transformer. 3 single phase transformers 11 by 33 kV are connected as 3-phase transformer with a phase sequence ABC, okay, like this connected. So this is ABC sequence according to terminal names. No, this is A2, A1. Dotted terminals always even numbers. This is B2, B1. This is C2, C1 connected, C1. Similarly here ABC sequence. This is A2 and here A1. This is B2, B1 and here C2, C1. Now however we draw in actual classes connections, same as it is you draw. Let's check which connection we are getting for this. See that. Let's see which connection we will get here. First, draw the primary side delta. So A2, A1 and A1 here joined. This is A1 joined with B2. A2, A1. A2, A1. A2, A1. And A1 connected to which terminal? B2 terminal. Now this is the B2 terminal here and B2, B1 like this. Clockwise ABC sequence it is taking. B phase, this is A phase and the C2, C1, B1 connected to C2 terminal. So C2, C1, C2, C1, C phase it is. So this is a primary delta. Now secondary delta based on given, let's see, based on this A1, A2 joined with B1 here. A2 joined with B1, A1, A2, draw A1, A2 exactly in phase with primary phasor A1, A2. Next A2 joined with B1, no? A2, this is B1 point. Now way to draw B2, B1, B2, clockwise ABC sequence should be there, B1, B2, remaining C1, C2, like this we got. Okay. Now for clock connections, generally we draw internal star phasors whenever there is a delta for easy understanding. Now here draw the internal star, which is the source terminals taken. Here A2, B2, C2 are the source terminals. Load also A2, B2, C2 only. Now accordingly this is A, this is B, this is C, and secondary side which is the load terminals again A2, B2, C2 only. So draw internal star here. Then this is A here, A2, this is B and this is C. So when you keep it in a clock, capital A pointing towards 12 only and very small a is pointing, this is 6, no, this is 6. So between every two phases 120 degrees means 4 digits. Then if you take from here 4 means from 6 4 digits means 10 we get. This is pointing towards 10 it is, and here 11, here 12. Now secondary phase A leads the primary phase A. Okay, we can call it is 40-degree leading connection. Actually, in delta delta we never use practically this vector group does not exist. Okay, but here it is given. So in the options we have dd0, dd6, dd10 and dd4 something is there like this. So the answer for this will be delta delta 10 o'clock connection it is. So dd10. Okay, now so these are the questions available from the machines we have with the data available. Okay, you cross check some of the values whether it is exact values or not. So little verify this. Okay, so these are the questions from machines we have.
So this is a given system expression, t square y double dash t plus 7t y dash t equals to sin t. Indirectly that fellow is saying this is the input. The input and output are described by this differential equation. Asked about the system properties, is it linear or non-linear, time invariant or variant. Very clearly according to the given expression it will look like linear, but the coefficients are external function of time, the t square as well as t, that indicates time variant nature. Very simple question. No non-linear elements, so system is linear. Time variant, coefficient is external function of time. That fellow feels that this is the input, sin t is the input. This is one question we got. Another question is, this is a funny question. This is the signal expression given, we want the ROC of yn. We are aware a power mod n is combination of a power n for positive index, a power minus n for negative index. It will have common ROC that lies between a to 1 by a under the condition mod a less than 1. So the given signal is simply 0.9 whole power n for positive index, 0.9 whole power minus n for negative index. According to the standard relations, this is like 0.9 whole power n un. This can be written as 1 by 0.9 whole power n u minus n. For this mod z greater than 0.9, for this mod z less than, because it is left sided, roughly it is 1.1, 10 by 9. So the intersection ROC lies between 0.9 to 1.1. What is the common ROC? Last year, this is given as an additional question for electrical students. This year, he framed with a number 0.9. I think we have one more question. Mr. Aditya will handle that.
So students, this looks like a theoretical question. So they say that x of t is a periodic signal whose time period is capital T, and they are trying to sample that signal with sampling time as Ts, and then they are talking about the resultant discrete time signal. So under what conditions this is said to be periodic? So that's the question. Now it's a very standard thing that we discuss in the class. We talk about periodic signals. We talk about continuous time periodic signals as well as discrete time periodic signals. So let's look at this. You can also solve the problem like this. Let's take x of t as cos omega m t. You can write this like cos 2 pi fm t. Now you want a discrete time signal. So what we usually do is we replace this t with nts. So once you replace that, you get a new signal. So let's write in short that x of n is cos 2 pi fm, and then this t is now replaced with nts. And we also know the relation between the fundamental frequency and the time period. Fm, you can replace this with, so cos 2 pi fm is 1 by t, so this is something like nts by t. So try to group it properly. So this looks like cos 2 pi ts by capital T into n. Let's compare this with this expression cos omega naught n. So now this is a discrete time periodic signal. You would have studied when is cos omega naught n to be a periodic signal. It is periodic when 2 pi by omega naught is a rational number. 2 pi by omega naught should be in the form of what? Rational number. Now what is omega naught on comparing? So here you have omega naught and here you have 2 pi ts by capital T. Just substitute that. So this is 2 pi, and what is omega naught? It is 2 pi ts by capital T, and after cancellation it is t by ts. I want this ratio to be rational number. When this ratio turns out to be a rational number, that's when the resultant discrete time signal is said to be periodic. If you can see the options, it says x of n is always periodic. No, we have this condition. X of n can never be periodic. It can be periodic. X of n is periodic for all values of t by ts. So we have been saying that this ratio has to be rational number, which is clearly in option D. So we also got a question, we heard from the students that there is a question from Fourier series where a sawtooth waveform is given and some kind of odd harmonics, like waveform is given. Based on that, we need to identify what kind of harmonics are there. If you can pose that question to us, we will discuss them in detail. So we have next faculty, so controls. So we have Venkatrao sir discussing engineering mathematics next.
In control system, we received 3 questions. So, if anything left, again at the end again I will discuss it. So, first question, it is easy question, they asked in the border plot. The initial slope is minus 20. So, simply the transfer function is g of s equal to, so some k divided by initial slope minus 20 means one pole at origin. Here change in slope, here slope is changed, change in slope is what? Here it will become what? Plus 20, plus 20 means 0. So, that means what you will get? 1 plus s by omega naught. I think here there will be a 0 dB. So, that means what? K will become 1, 0 at omega equal to omega naught equal to 20 log k, yes or no, 20 log k minus 20 log omega. So, you substitute here omega equal to omega naught, you will get k equal to 1 you will get. So, that means answer you will get it what? C. Next one. So, the given transfer function of step response is given. So, that means it is no feedback is mentioned, that means it is a open loop system. So, open loop transfer function mentioned y of s. Na? So, y of s by if you take r of s is a step response mentioned equal to g of s. That means y of s equal to what? G of s into r of s. So, that means g of s, r of s is 1 by s. That means g of s becomes what? 100 by s plus 100. It is a simply first order system. So, time constant is 1 by pole location, 1 by 1 by 100. So, time constant 1 by pole location, 1 by 100, no, minus 1 by 100 you will get. So, 0.01 second is time constant. So, rise time for first order is 2.2 tau. So, if substitute it, you will get what? 0.022, 0.022. Then next one is what they are asking, settling time. Settling time Ts is what? 4 tau. 4 tau means here 0.01, so 0.04, and next time constant 0.01. So, answer B. Next here they given a state model, just they are asking the what? AB, you find the transfer function. So, no need transfer function, characteristic equation is enough. So, what is the characteristic equation? Det of Si minus A equal to 0, add S diagonally. So, what you will get? S here minus A, here minus B, here A, here it will become S equal to 0. So, what you are getting? S into S minus A plus AB equal to 0. So, S square minus AS plus AB equal to 0. So, for given data, if write characteristic equation, so what is given data? S plus 2 whole square plus 9 3 square equal to 0. So, what you are getting? S square plus 4S plus 13 equal to 0. If you compare it, A equal to minus 4 you are getting, and AB equal to 13, AB equal to 13, A equal to minus 13 by 4. So, that means minus 3.25. So, that means answer is D. That's all. Next, math sir will continue. Venkatrao sir.
Hi students, engineering mathematics, actually we have just received only 2 questions. So let me complete this. Later on if new questions arrive, then we'll do those questions as well. So one of the question from vector calculus regarding f bar of xyz equal to sin y into x cap, I mean I cap, cos x into y cap, I mean j cap, phi z cap, it is not phi z, phi z cap means phi cap. What is integral f bar dot ds over unit sphere? Unit sphere, you remember that. So unit sphere, it is a Gauss divergence theorem. So according to Gauss divergence theorem, double integral f bar dot n cap ds, that is equal to triple integral div f dv. So divergence, what is divergence? Sin y derivative with respect to x partially 0 and cos x derivative with respect to y partially 0, and z cap means k cap means phi coefficient derivative with respect to z partially 0. So answer 0. In case it is a phi z into k cap or phi z into z cap, then answer should have been 20 pi by 3. I mean 5 into volume of the sphere, that is 4 pi by 3, that is 20 pi by 3. I came to know that it is only phi z cap. In case it is phi z into z cap, answer will change. Now look at this question. A and B are two n by n matrices with same eigenvalue and the corresponding eigenvectors are same. Then which of the following statements are true? It is MSQ, one or more options correct. As you all know, A is a 2 by 2 matrix, so it will have one of the eigenvalue given to be 2. If one of the eigenvalue is given to be 2, then I can write Ax equal to 2x. So that is A minus 2i into x equal to 0. So to get the eigenvalues, I can write determinant of A minus lambda I. So determinant of A minus lambda I, so that is A minus 2i equal to 0, and hence accordingly option D correct. Moreover, matrix B will also have same eigenvalue. So therefore Bx equal to 2x. Accordingly B minus 2i into x equal to 0. So it will also satisfy magnitude of B minus 2i equal to 0 regarding eigenvalues. So and hence option B correct. Now option A correct, option B not correct, and C correct. Let me say, look here, A is a 2 by 2 matrix, Ax equal to 2x, because one of the eigenvalue 2. B is also, A is a n by n matrix with one of the eigenvalue 2. B is also another n by n matrix with one of the eigenvalue 2. So from this I can write Ax plus Bx equal to 4x. So from this A plus B into x equal to 4x. So therefore it is A plus B x minus 4i into x equal to 0. So from this A plus B minus 4i into x equal to 0. If you want the eigenvalues, we have to write a determinant of A plus B minus 4i equal to 0. So to get the eigenvalues of that, we would have written determinant of A plus B minus 4i equal to 0, and hence option C correct. So accordingly option B eliminated. So actually as of now we just received only 2 questions. So still we have few more questions from other subjects also, other topics also in engineering mathematics. Soon we will update. Next Kiran sir, analog, he will continue.
Hello everyone.
let us now discuss the questions from subject power electronics. Here altogether we got around 6 questions we received from subject power electronics, and based on the memory based questions, here I have collected a few questions. Let us discuss. The figure shows a straight line approximation for the forward characteristic of a power diode. This is a power diode forward characteristic. Simple. A continuous on state current is 15 ampere, means they are saying the on state current is a constant 15 ampere. So it is a DC current is flowing through the diode. What is the power loss in the diode, right? So our task is to find the P average in the diode. By default power loss means P average. We know from the piecewise modeling of devices, the diode belongs to the third modeling. Third modeling is Vt in series with the R1, right? So here third modeling, that is Vt in series with the R1. And for third modeling, what is the power loss expression? P average equal to Vt into I average plus I RMS square into R1. I RMS square into R1. Now from this characteristic we need to find what is the Vt and what is the R1, right? So if you check during our classroom sessions also, we discussed this indicates your Vt. In this case Vt is 1 volt, right? And R1 is nothing but if I check the slope of this line, slope is nothing but change in current to the change in voltage. So change in current to change in voltage means it is the ratio of current to the voltage, that is 1 by resistance. Alright. So from this plot I can write Vt equal to 1 volt and R1 or 1 by R1 equal to slope of this line. What is the slope of this line? Slope of the line is change in y upon change in x, that is 50 minus 0 upon 1.8 minus 1. So that is 50 upon 0.8, that is a 1 by R1. So what is R1? R1 equal to 0.8 upon 50. 0.8 upon 50. This is my R1. So Vt and R1 we have written. Current they are saying it is a constant current, right? If current is a constant, average value, RMS value both will be same. So from this can we write P average? Yes. So from this P average equal to Vt is 1 volt into I average. Average value of the current. Current is a constant, that is a 15 ampere. So average will be the amplitude, that is 15, plus I RMS square. If current is constant, its RMS value also same, that is the amplitude. So 15 square into R1, that is a 50 upon 0.8. Sorry, 0.8 upon 50. Let's correct it. This is 0.8 upon 50. Right. 0.8 upon 50. Yes. If we simplify this, we'll be getting it as 18.6 watts. 18.6. So option D is the correct option for this question. Next question. This is a simple circuit, single phase half wave uncontrolled rectifier RL load. We have done the analysis, right? Consider the circuit shown. Assume that the diode D is ideal. Supply voltage given 325 sine of 2 pi 50 t. So pure sinusoidal supply. Inductor given 50 microhenry and R is a 10 ohm. And they are asking the peak diode current. Peak value of the diode current is nothing but peak value of load current, right? ID and I0 both are same, right? So ID peak, what is the expression for ID or I0? If you check during our sessions we have written I0, which is equal to, in this case ID, equal to Vm upon mod Z sine of omega t minus phi plus sine of phi into e to the power minus RT by L, na? Right? Actually we have done this RL load for controlled rectifier, but in controlled rectifier if I put alpha 0 degree, I will be getting the diode rectifier, right? Now from this, if you check this term, it indicates your transient response. So at steady state my peak value will be only Vm by Z. Yes, in expression here also we are having the Vm by mod Z. So what is the peak value of diode current? ID max equal to Vm by mod Z simply. What is Vm? 325. upon mod z under root r square plus omega L square. R is 10 square plus omega 2 into pi into frequency is 50 hertz into L. L is a 500 micro, 500 into 10 to the power minus 6 square. Yeah, if you simplify this, you will be getting it as a 32.5 ampere. 32.5 ampere, right? Second question. Next question. Here he has given the boost converter. Circuit diagram. This is a boost converter. Inductor is connected at a source side, so boost converter, right? Assume that the semiconductor devices are ideal. In steady state, the inductor current rises linearly from 0 to 6 ampere. Linearly from 0 to 6 ampere in the first 10 microsecond and falls linearly from 6 ampere to 0 ampere in the next 10 microsecond of every switching cycle. Means here he is saying my inductor current waveform is this type. Inductor current waveform increases, decreases, again increase, again decrease. This time is a 10 microsecond. This time is in microsecond. This is 10 and this is further 10, so it will be 20 in this case. Current increases from 0 to 6, so peak value will be 6 ampere. Peak value is a 6 ampere. Now what is the conduction type? This is just continuous conduction. Conduction is a just continuous. And what is the on time? This time indicates the on time. And what is total time? This is my total time T. In DC to DC converter, this is a T on, this is a T off. Addition of on and off time is total time. Alright, next. And here they are asking if the load resistance is of 10 ohm and capacitance given, and our task is to find, anyways here he has given the waveform. Neglecting this, our task is to find the input voltage VDC. We need to find the VDC, right? How to find the VDC? If this is my inductor current waveform, right? So T on and T we got from this waveform. From this I can write T equal to D equal to T on by T. Duty cycle is equal to T on by T. So duty cycle T on is 10 micro upon T is 20 micro. So D equal to 0.5. Duty cycle is 0.5. Now if this is my inductor current waveform, what is IL average? IL average equal to, I min plus I max by 2. I min is 0. 0 plus I max is 6 upon 2. That is 6 by 2 means 3 ampere. So my IL average is 3 ampere. Now by using ampere second balance equation, we can write IL average equal to I0 average upon 1 minus D, right? IL average is 3 ampere, which is equal to I0 average upon 1 minus D. D is a 0.5. From this we can get I0 average. I0 average equal to 0.5 into 3, that is 1.5 ampere. This is my load current, right? I0 average. And they are asking what is the input voltage. Now if I0 average is 1.5, can I write V0? V0 average equal to I0 average into R. It is 1.5, and load resistance, he has given the load resistance value as a 10 ohm, right? So into 10, this is equal to 15 volt. So my V0 average is 15 volt. Now from this I can write for boost converter, what is the expression for V0? It is equal to Vs upon 1 minus D, right? And now it is a 15 equal to Vs upon 1 minus 0.5, correct? So from this I can get Vs equal to 7.5 volt, alright? Input voltage 7.5. So correct answer is option D, right? Next. Check these type of questions we discussed during our sessions. He has given voltage, current expression, but voltage is pure sinusoidal. Current is having the harmonics present, right? 50T, it is a 150T. So this is a fundamental, this is the third harmonic, right? Now how to find the power factor? We know power factor equal to P upon S, and now P equal to P1. Check similar type of question they asked in gate 25 or 24 somewhere, and these type of questions we discussed during our classroom sessions also. Even in our practice questions we discussed this question. P equal to P1 equal to Vs RMS into IS1 RMS into cos of phi 1. Now Vs RMS, supply voltage pure sinusoidal, so RMS is 325 upon root 2, peak by root 2, that is RMS. Fundamental component of source current, that is 12, is a peak value, 12 by root 2, 12 by root 2 into cos of phi 1. What is the angle between these two? It is 2 pi 50t, 2 pi 50t, so angle will be 0, so it is cos 0, right? So this will be like 325 into 12 upon 2, right? So if you check, yes, yes, yeah, 325 into 12 upon 2, you will get it as a 1950 watts. This is my P, right? Next, apparent power, yes, S is equal to Vs RMS into Is RMS. But what is Is RMS? Is RMS equal to under root Is1 RMS square plus Is3 RMS square, right? So it is equal to under root Is1 RMS 12 by root 2, Is3 RMS 9 by root 2, right? Simplify this, you will get Is RMS is equal to 10.6 ampere. Now what is apparent power? Vs RMS into Is RMS. Vs RMS is 325 upon root 2. Is RMS 10.6, right? So this will give you a S value which is equal to 2436 volt ampere. And now what is the power factor? Is equal to P by S. P is a 1950 upon S 2436. If you simplify this, you will get it as a 0.8, right? 0.8. Yeah, next question. Yeah, yes, I think in this question, yeah, they have asked about the RMS value of diode current, ID RMS value of diode current they have asked, right? Which circuit is this one? This is a single phase full bridge inverter. Load is purely inductive, right? We know when single phase full bridge inverter or half bridge inverter, when load is purely inductive, nature of load current is a triangular, and here he has given the load current waveform which is a triangular in nature. Peak value of load current is a 5 ampere, right? And this is my time t. This time is in, yeah, yes, this is a 5. I think this time he has mentioned in microsecond. Okay, there is some we don't have the clarity because this is a memory based question. Okay, let us take it as in microsecond, right? So 0 to 5 microsecond, 5 to 10 microsecond, 10 to 15, 15 to 20, right? Now if you recall our analysis, we know this instant indicates a t by 4. This instant is t by 4. This is t by 2. This is 3t by 4. And this point is a, yes, this is 3t by 4. Yes, this is 3t by 4. And this is like a t. This is a t. check T by 4, T by 2, 3 T by 4 and T. Alright, this point is T, this point is T, right. Now for purely inductive load during, yes, from 0 till this interval, how is the conduction sequence of devices? If you recall conduction sequence of devices, here we are having the S1 conduction, after that D1 conducts, next to that S2 and next D2, means my conduction sequence is like this: S1, D1, S2 and D2. I am starting from T by 4 and I am completing at 5 T by 4. T by 4 to T by 2, T by 2 to 3 T by 4, T by 4, T by 2, 3 T by 4 and here it is a T, right. So this is our conduction sequence of devices, right. Now for this operation, if we draw the waveform for diode current, how will be the diode current waveform? We will be getting the triangular type of the waveform. Any one diode you can take, T by 4, T by 2, 3 T by 4, T and 5 T by 4 and so on. If I draw the waveform for diode current D1, let us take this current as a D1. Yes, my conduction sequence is my D1 conducts here T by 4 to T by 2, S1 conducts. After that D2, S2 and D1, and in continuous cycle operation here also it will conduct the D1. So my conductions, if conduction sequence is this one, my diode current waveform will be getting this type of, that is triangular, and this current is same as the top peak value of your load current, and same you will be getting here. If this is my diode current waveform, if this is the diode current waveform, then what is the periodicity? Periodicity is obviously T. For triangular waveform, what is the RMS value? We know RMS value of triangular waveform, ID RMS, amplitude square by 3, amplitude is 5, 5 square by 3, function duration T by 4 upon periodicity T to the power 1 by 2, right. Yeah, if you simplify this, you will get it as a 1.44 ampere. Right. So already we discussed a purely inductive load, right, but here he is asking a diode current RMS value. So you need to understand the waveform of the diode current, right. Simply check the conduction sequence, from that you will get idea. Yeah friends, these are the questions from power electronics. Now the Kiran sir will take will discuss the questions of analog electronics. Hello students, I have received 2 questions from analog circuits. From op amp, you are asked to find the output voltage if a finite gain is given.
So, this is the question. The input is also given as 100 millivolt. Okay, so find V naught. This is the question. So, let us solve. Since the gain is finite, you are not allowed to apply virtual short. Okay. So, you have to treat a op amp as a general configuration. V naught is A times of V1 minus V2 and substitute the values, so that you will get the answer. V1 is already 0. So, what is A? A is 105, and V2 you can apply superposition theorem, or you can apply KCL also. Superposition is fine. So, what is V2 if I ground V naught? It is 100 millivolt into 100K by 105K plus ground 100 millivolt because of V naught, it is V naught into 5K by 105K. So, now you can easily find V naught, that is the solution. So, let us solve V naught into 1 plus, here we have 105 into 5K by 105K. Here 105 into milli and K cancel. So, it is 10K by 105K. So, now you can clearly see what is the answer. 105 gets cancelled. Here 1 plus 5 is 6, there you have 10 by 6. So, it is 1.66 volts. This is the solution. Okay. So, it is a simple substitution problem. V naught you are asked to find, V1 is 0, V2 in terms of V naught I have used the superposition theorem. Okay. So, let us see next question. Here a Zener diode is given, a regulator problem. If I remember, I was told the Zener voltage is 5.4 volt, the forward drop is 0.6 and there is a current source given 100 milli. The series resistance here is 5 kilo ohm and the supply voltage is 10. So, this is the problem given. Now, what you are asked to find? You are asked to find the power efficiency, which is power output by power input. So, let us start the solution. Power output, power is voltage into current. Voltage is 5.4 minus 0.6 is voltage, current is 100 milli. This is power output. What is power input? Power input is V into I. So, here we have a summation here. So, let us take V is 10, I is 10 minus 5.4 by 5K plus IC. Since beta is given infinite in this problem, I am taking 100 milli. So, now it is a simple calculator work. Power output by power input you have to do. Power output by power input is found to be 47.5%. So, this is something I remember. Over to the next faculty.
Well, coming to the digital electronic questions from electrical paper, find the output F. And there are 3 logic gates available at the input port, one NOR gate and 2 AND gates. So, simply AND gate is not going to receive any common terms. If you observe the things carefully, you can easily answer it, or otherwise you can write output expression. F is equals to AND operation of these 2 node equations. What is the Boolean expression at this node? X plus y plus z whole bar. Dot. This is x bar y plus again x bar z, x bar z, and these 2 lines are connected to AND gate. Let me apply De Morgan's theorem here, then it will be x bar dot y bar dot z bar into x bar y plus x bar z, y into y bar 0 plus z into z bar 0. So, f is equals to 0. Actually, we did not receive the options for this question, but the answer is 0. And strictly speaking, we do not have MOS logic in electrical paper gate syllabus, but we have discussed the transistor logics or logic family, or strictly speaking transistor and resistive logic. So, if you simply replace, we have done this kind of circuits with the transistor. If you replace transistor with MOSFET, transistor or MOSFET in digital electronics can be treated as a switch, just on and off switch. High voltage at input can be turned on, low voltage at the input can be turned off that particular transistor. And if you observe the things carefully here, simply this is an inverter, right? It is an inverter, resistor and one transistor, maybe metal oxide semiconductor field effect transistor. So, as it is an inverter, what is output of this? C bar. We need to take the output here, okay? We need to take the output here, and this is a pull-up resistor with a positive power supply, and this is an NMOS logic. So, directly you can apply that logic like NMOS logic. If transistors are connected in series, just do AND operation. If they are in parallel, do OR operation. And do not forget to take whole bar, we know that. So, that this is C bar. So, what is the output here? Output is equals to AB plus input is C bar whole bar. Then if you apply De Morgan's, AB bar dot C double bar, AB bar dot C. AB bar dot C is given in option D, of course, and in some of the students have sent the options some different from these options. Anyways, we will verify once if original key is released. And another question from this area is not only output Boolean expression, he is asking about the maximum power dissipation. So, what is the condition to get maximum power dissipation in the circuit? If current is passing through both the resistors, that is a condition to get the maximum power dissipation. So, power dissipation is equals to VDD square by pull-up resistor, VDD square by pull-up resistor value. If this branch is turned on, whatever may be the condition, A and B should be 1 and 1, then this branch can be turned on, then we can expect the current through this branch. So, this is a case 1 of power dissipation, case 2 of power dissipation, and case 3 all the transistors may be A, B as well as C may be turned on. There is a condition, A, B value may be 1 and C also may be 1, then there is a situation to find the maximum current through branches, hence we can get the maximum power also. If only this branch is having some current, what is the power dissipation? Power dissipation for the case 1, if only A and B values are 1, 1, 5 square by 5k, and if this branch is turned on, VDD square by 10k, right. So, 5 milliwatts and 2.5 milliwatts, but if both the transistors are on, then we have to consider this entire network into the consideration. So, that what is the power dissipation? VDD square, that means 5 square divided by R1 parallel R2, because these resistors will come to the parallel combination R1 R2 by R1 plus R2. If you substitute, you will get here 25 by 5K, 2.5 milliwatts, and this is 5 milliwatts, and this is a 7.5 milliwatts, and 7.5 milliwatts is a maximum power dissipation. So, 7.5 milliwatts and AB bar dot C, but you no need to worry about the power dissipation because logic is satisfied by only one option. If these are the options really provided in the options, I mean in the paper, then happily you can select option D. You can ignore the power calculation because this option is matched with D only, right? These are the questions found in digital.
Hi students, so here I am going to deal with the questions which are related to the electromagnetic fields. So right from the inception is keep on increasing the numbers, is keep on increasing the weightage in this subject. So unbelievably this year also there was 6 marks was asked from this subject. There was a 2 marks questions and 2 1 mark questions. Totally it is a 6 marks, fine. So here is the questions. So just I wanted to make them very concise and very precise because the question paper is not out yet, fine. So here is a uniform ring charge of radius r carries a total charge of q. If a point charge of a small q is kept at the origin, what is the force on it? It is a 1 mark question, fine. So here without knowing the formula you can answer this. So it is a uniformly charged one. So it is asking what is the electric force if some charge q is kept. So this was uniformly distributed, the charge is distributed uniformly over this, the total charge is q. You can apply the symmetry concept here, fine. So as it is a symmetrical charge distribution, the electric field is 0 here, fine, due to this one, due to this one, due to this one, due to this one. So here the electric field is 0. So as the electric field is 0, obviously electric force will also be 0, fine. So what is the answer guys here? So option B is the answer. It was a 1 mark question. So the other question here, yes, so this was also 1 mark question. So this question is on the Lorentz force relation. The charge is entered into the entered with the velocity v in the presence of both electric and magnetic fields. So it's asking some conclusions here, fine. You can read out those conclusions here. So we can make use of what is called a Lorentz force. So what is the total force here? It is q into E plus V cross B, fine. You can read out those options here. You are aware of that. So the charge value is not given because in the options is asking just the direction, is asking us to comment only on the direction. So the electric field here is phi y cap plus with the velocity is phi x cap cross B. What is the B? It is minus 6 z cap, fine. So here q into phi y cap
x cross z is minus y, already one more minus is there, it is a plus. So, it is a 30 y cap. So, you can just observe the conclusions here. So, the charge which is entered is the x direction, the force acting in the yes. So, the how the force is in the direction of electric field, the force along the magnetic field, no, the force is along electric field but perpendicular to the magnetic field. Yes, option D will be the correct, you can read out them. Why? Because so the force here to the electric field, it is the same direction, but to the magnetic field, so the magnetic field is in the z but magnetic force is in the y, so it is the perpendicular. So, option D will be the correct. Just it is a 1 mark question. Fine. One more question. Yes, here you need to think little bit. Let me cross check the data here. Yes. So, it is asking, just read out the question here. Let me cross check the data. Yes. So, here is a 3 by pi 10 to the power of minus 6, and then q is equal to, yes, pi into 8.85. Yes. So, this is a minus 3 0 comma 0 comma minus 3 comma 0 comma minus 4 0 comma, yes, correct. So, read out the question here. This was a 2 marks question. It is a numerical answer type question. It is a 2 marks. So, uniform spherical volume charge distribution of radius 2 meters and centered at the origin has a volume charge. It is rho v. Fine. The volume charge is given. A point charge of q is moving from initial point minus 3 comma 0 comma minus 4 to final point 0 comma 0 comma 4. What is the work done in moving a point charge from initial to the final point? Fine. So, let me take some rough diagram here to handle this one. So, there is some charge here, guys. There is a charge here. Fine. So, this is having a radius of 2 meters. So, there is some initial point, final point, we do not know where they are. Fine. So, you can find out where is the initial point, you can make a comparison with respect to the origin. So, what is the distance with respect to the origin? So, the distance with initial point with respect to the origin is square root of minus 3 square. So, it is 9 plus 0 square plus 16. So, which is equal to square root of 25, which is equal to 5. What is the final point? What is the distance of the final point? So, the distance of the final point, you can make a comparison of this point with respect to the origin. So, which is, it is a 0 square plus 16. So, this is equal to 4. So, with respect to the origin, where is the initial point? The initial point is at a distance of 5 meters. This is the initial point, and the final point is at a distance of 4 meters. So, it is asking what is the potential at the final point with respect to the initial point. Yes, which we know that V into a potential. Yes, not I am sorry, this is asking for work done. So, the work done is equal to Q into final point and initial point. Fine. So, which is equal to Q into final point minus initial point. So, these 2 points are outside the sphere. Once you are outside the sphere, whether it is a point charge or spherical charge, doesn't matter. Once you are outside that, it will going to behave like a point charge itself. Fine. So, you can make use of this formula. What is the potential due to the point charge? It is Q divided by 4 pi epsilon naught R. So, bring everything and substitute there. So, what is the work done here? The work done here is the charge is given. It is pi into 8.854 into 10 to the power of minus 12. Fine. Into final potential. So, you can find out the total charge. What is the total charge here? Volume charge is given. So, the volume charge 3 by pi into 10 to the power of minus 6 into what is the volume, isn't it? Once you are outside, it will be going to behave like a point charge. Yes. What is the volume of this? 4 by 3 pi r cube. It is a 2 cube. Fine. So, the q is equal to pi will go, this one will go, this one will go. So, this will become, so 4 into 8 into 10 to the power of minus 6. So, it is, this one is a 32 microcoulombs. Fine. So, bring everything and substitute here. So, Q divided by 4 pi epsilon naught. What is the final distance? The final point is 4. Fine. 4 minus Q divided by 4 pi epsilon naught. The initial distance, initial point is at 5. So, bring the constant data outside. So, pi into 8.854 into 10 to the power of minus 12 into what is the charge, guys? The charge is 32 micro divided by 4 pi into epsilon naught value is 8.854 into 10 to the power of minus 12. So, it is 1 by 4 minus 1 by 5. So, I think this value will turn out to be 0.4 micro Henry. You can check out, you can do these calculations. I will leave this one to you, 0.4 microjoules. So, anyhow, he is asking the this in terms of the microjoules. So, 0.4 will be the answer. Okay, go through this numerical. Fine. So, there is a one more question here which we have not printed. So, but there is some data available here. So, based on that I will try to answer that. So, the question here is, just a second, let me add some pages. Yes. So, just a second guys. So, here is a question. It was on the Faraday's law. If I am not wrong with the data. So, the coordinate x, y, z, fine. So, there is some loop is given here. We call this as a loop A, and there are two more loops are there. It is a loop 1, and this is having a area A1, this is having area A2. Okay, and the magnetic flux densities which are enclosed by them are also mentioned in the question. What they are? So, it is m divided by root 2 sin omega t, and then x cap plus z cap. So, this was a given data, and the magnetic flux density which is linking with the loop 2 is also given. So, which is minus n divided by root 2 cos 2 omega plus pi by 4, okay, y cap plus z cap. So, this is a given data. Is asking what is the EMF induced in the loop A, fine. So, obviously, how do you find out the EMF induced in the loop? So, EMF induced in this entire loop. So, the EMF induced this entire loop is equal to EMF induced in the loop 1 and loop 2, fine. So, these loops are kept under the influence of magnetic flux densities. So, we can make use of this. It is a dou by dou t of surface integral of B dot dA. So, there is a dot product here, fine. So, the area direction is a normal direction, fine. So, this one, this is a z cap, area direction, here also area direction. So, the only z component will going to contribute for this. So, you need to pick up this one and this one. You no need to do any integration here, fine. So, I will going to turn the page here. So, finally, I will going to write. So, what is the EMF induced? It is EMF induced is equal to d by dt of flux. What is the flux, guys? Flux density into area. Flux density, what is the flux density? It is m by root 2 sin t, and only z component will going to contribute for that, fine. So, which is 1, you can just leave it. And what is the area of that one? It is the A1 plus d by dt of flux. What is the flux? Will be contributed only by the z component. So, it is minus n by root 2 cos 2 omega t plus pi by 4 into z cap, fine guys. Okay. Now, simplify this one. Is asking what is the RMS value, fine. So, to differentiate this one, you will going to get here omega, do not forget. So, it is m into omega into A1 divided by root 2 into cos omega t plus this one cos differentiation is minus 1, already 1 minus is there. So, it is a plus. So, it is n into 2 omega divided by root 2, fine, sin 2 omega plus pi by 4, correct. Okay. Now, he is asking, this is the form you have, he is asking what is the RMS of the resultant one, fine. So, these two are orthogonal signals. When the orthogonal signals are there, what is the resultant RMS? Resultant RMS is equal to individual RMS squares, RMS 1 square plus RMS 2 square, fine. So, what are the individual RMS values? Yes, so it is the m omega A1 by root 2 divided by root 2 whole square plus 2 into n into omega by root 2 by root 2 whole square. Fine. So, finally, this will become m square omega square a1 square plus 4 into, just second, 4 into n square omega square a2 square. Don't forget there is a a2 here because you need to multiply with the area. Fine. So, there is a a2 here, a2 square divided by 4. Fine. So, numericals may go here and there because we do not have a proper input, proper questions and variables. Variables may go here and there, but this is the essence of the solutions. One should understand. Fine. Yes. So, options were given. So, from those options you need to answer that. Fine, guys. Anyhow, see here, this entire session was just to give you some idea regarding, just second. So, this entire session we have these are the questions we got from the various sources, the different things. Fine. And these are all about the technical part. Fine. So, our other faculty member will going to deal with the questions related to the your aptitude. Fine.
Okay, my dear friends, from the students information we are getting some memory based questions. Okay, so from the memory based questions we discussed the those questions only, and one of the question, first missing number point of view. They given here 3, 24, 120. What is the next number? Okay. So, my dear students, easily are getting this answer. I hope everybody also getting this question. So, here triangle 3 sides. Okay, triangle it is 6, I think. Yeah, 6 only, right? 24, 120 and a question mark. So, triangle 3 sides. So, 3 factorial. Here 3 factorial, 4 factorial, 5 factorial and a 6 factorial. Then answer is 720 is the answer, my dear friends. I hope every student also getting this question. Okay. And next one, P and Q, two positive integers. P and Q, two positive integers. So, P square is equal to 13 plus Q square. P and Q positive integer, my dear friends. Then what is the product of the P and Q? What is the product of the P and Q? Okay, my dear friends. So, here you can simplify P square minus Q square is equal to 13. A square means B square, P plus Q into P minus Q is equal to 13. Two numbers product to 13. 13 is a prime number. 13 is a prime number means 1 and itself only, right? So, then P plus Q 13, okay, P minus Q 1. So, it is 1, 13 or 1, your wish. So, you can simplify 2P is equal to 14, P is equal to 7, P value 7. P value 7 means automatically Q value 6. I want product of those two numbers, so P and Q. 42 is the answer. Okay, my dear friends. And one more question getting from the mensuration. There is a circle diameter where center we form two triangles. We have formed two triangles, and from this sides again formed. They are asking this value theta, P, Q, R, S, T. Okay, my requirement, my P, T, Q. What is the answer? This is center O. You can observe, my dear friends. Okay, here angle given already, 80 given already, 80 given already. Okay, now you can observe here. This is also radius. This is also radius. Two sides equal. Two sides equal means their opposite angles equal. It is isosceles triangle rule. Okay, so their opposite sides here, these two equal. And remember, this is also same. This is also same. Okay, this one you can take x. This one also you can take x. Sum 180. 2x plus 80 is equal to 180. Okay, then 2x is equal to 100. X value 50. X value 50. Okay, this is 50. Then automatically 65 and 65, because sum of interior angle is 180. Triangle 180. This is 65. This one also 65. Now you can observe triangle P, T, Q. Sum of the interior angle 180. So 65 plus 65 plus you can take a theta. So 180 is equal to 130 plus theta. So theta is equal to 50 degrees. Theta is equal to 50 degrees. Okay. This time, my dear friends, 90% of the students, every student also easily getting the questions from the general aptitude. Okay. So whatever we teach now, whatever we discussed till now, these are everything purely memory based questions only. Okay, within as early as possible we are getting the correct question paper. Okay, 100% accuracy we are giving the questions and solution to you. We will provide as soon as possible. Thank you. All the best, all of you. Thank you.